Firstly, I'd like to thank the Nuffield Farming Scholarships Trust for providing opportunities not only to myself, but to dozens of individuals across the globe each year. Secondly, the NFU Mutual Charitable Trust for sponsoring my scholarship. I certainly hope some of my findings will be very useful towards business models from here onwards in terms of investment and insurance and responsibilities and liabilities. And finally, I'd like to thank Clive and Sue Blacker from Precision Decisions, wherever they may be, for affording me the time off from a very busy year to actually complete my travels. I'm sure at the other end of the phone I was quite waspy when I was getting phone calls in obscure time zones. So, autonomy in agriculture, what does it mean? To some of you in the room, it might quite simply mean self-governance, but unfortunately, I'm a technical person, so I'm meaning it in the sense of robotics, and automation and robotics. So, as many people doing research, I wanted to find out where the first conceived idea of robotics was. I thought maybe it was 15 years ago with the availability of public QPS systems. I was very wrong. I thought maybe 25 years ago with the availability of powerful computing or relatively cheap computing. I was very wrong again. The first reference I found to robotic farming in agriculture was in 1934. Put that into perspective, that's 14 years before the Nuffield Universal was even built. In the Popular Science Journal, they featured an article on the World's Fair where they were demonstrating a robotically controlled or remotely controlled tractor in a field. So the title says it all, Robot Plows Whilst Farmer Rests. Now I'm sure most people in this room will agree that's not quite happening. This raised two very obvious points. This is a generation ago, this is 79 years ago. What's happened in that last 79 years? We still don't have autonomous tractors running around the fields. Well, in reality, we have a very high standard of technology in tractors available today. They are completely fly-by-wire, they are completely computerized, even to the point where the flashing light on the top is powered by the computer or controlled by the computer. The only common element that remains is a human or the bum sat on the seat. So, the second point this brought out is there has been a long-needed desire or the want to separate the farmer from the dirt and the grime of turning soil. So I wanted to find out why this hasn't been pushed further. My travels took me through Italy, up to Germany, Denmark, Sweden, across to Australia, and finally into the home of robotics, Japan. There were a couple of establishments which I felt deserved special recognition, and I'll talk about them now. First of all, in Italy, Vislab, a company which is a spin-off commercialization department from the University of Milan, have been developing autonomous vehicles to operate on public highways. This was coinciding with the Defense Advanced Research Projects Agency, an American agency, to push these technologies forward. In 2010, to prove the concepts, they set off on an epic journey with 4 autonomous vehicles driving from Rome to Shanghai in complete autonomous operation. That's 13,000 kilometres of vehicles driving themselves on unfamiliar roads, with unfamiliar traffic conditions, with a range of variables which could not be foreseen. In 2013, earlier this year, they've improved upon the design where the vehicles will now follow all the road safety laws that have been applied in that particular region or country. Whilst I was there, I learnt a very important statistic, and it's certainly a statistic which those in agriculture can certainly sympathise with. 95% of road accidents are caused by human error. 95% are caused by human error. It's any wonder that we're actually allowed to drive a vehicle at all. So, from Italy, headed over to Germany, where I learned there's 2 clear concepts of robotics in agriculture. The large commercial partners are looking at converting what they know and what they already have, converting their large machines, making them robotic, making them autonomous. Whereas academia are focusing on smaller machines. Perhaps it's because of budgetary constraints or physical room in the research laboratories. Another interesting fact that a lot of you may have heard recently, this has come from Harper-Adams' Professor Simon Blackmore, says 90% of the energy which goes into tillage is actually repairing the damage put there by the machinery in the first place. 90% of the energy. With this in mind, I went to one of the large commercial manufacturers in Germany. I'll not say which one. Their robotics unit is looking at using a 500 horsepower machine. Certainly flies in the face against the messages coming from Harper Adams. 90% of our energy is repairing the damage that we're putting there in the first place. When I tasked them saying, do you think it's wise having a robotics platform that's so large, so heavy? And the answer was quite simple. It's taken us a very long time to get to the efficiencies that we see today in terms of the engine management, in terms of the harvest efficiencies, and all this happens to coincide and scale with the size of the machinery that you're using. I thought, fair enough, this is your business plan, this is the way you've done business for the last 50, 60, 70 years, and I'd imagine not wanting to change it overnight. But all the commercial partners that I visited have a robotics program in place that are ready to almost be launched to the public. So heading over to academia, this is one project which is certainly very, very interesting. This is Bonnie Rob from the University of Osnabrück. This is actually partnered with a commercial agricultural manufacturer as well as the automotive industry. This machine can do a whole range of field scouting activities. With a range of sensors on there, it has individual information about every single plant within that field. It has a unique reference for every single plant. As it's driving around, scouting, it is monitoring so many aspects about the physical plant growth. So growth rates, stem thickness, leaf reflectance, this whole range of information that can be gathered. This machine was actually displayed at Agritechnica this year, along with 5 other robotic platforms that I saw. And for those that have been to Agritechnica know that if you've seen 5 things, there's 5 more things that you've not seen. So it is certainly a growing market. The technology has got a new name for this. We're looking at plant-level agronomy, phytotechnology, looking at what the individual plant needs, looking at every aspect of the plant. So we can now target our inputs no longer at a field level, where we simply say it's a field of wheat, it needs 220 kilos of N. We look at what the individual plant needs and feed that individual plant. So this is another step on from precision farming, where we classify our field into different zones or management areas. We've gone beyond that. We now have the ability to look at an individual plant. So perhaps the technology that we use where we're spreading 36 metres needs to be completely redefined so we can treat individual plants. So, my key messages to the various people in this room, to the policymakers, the technology is there. The technology is coming around the corner. People will need funds to invest in this. It is going to be an expensive technology to start with. Be aware what these technologies can do and what they can't do, and be informed on it. Be proactive with your legislation. Robotics and automation, I'd imagine, scare insurance companies immensely because of who do you blame, who's responsible, who's liable, and all these things need to be defined because currently they are not. To the academics, the researchers in the rooms, farm managers need to be trained in a different area. We have a shortage of good engineering entrants in agriculture at the moment. We need to improve the engineering entrants in terms of electronic abilities, in terms of mechatronic abilities, and build upon sensor technologies, because they are going to be key to actually these technologies being utilised efficiently on the farm. For those people that are educating on future farm managers, there's going to be a whole range of information, whole new levels of information. We're going to be talking about GIS systems, geographic information systems, 3D mapping. All this extra layers of information needs to be interpreted and understood effectively to be able to improve the productivity and reduce the inputs on that particular farm. And to the researchers in the room, whilst travelling across Europe, I saw so much duplication of the same technology and research. It was very, very frustrating, very frustrating. So please make the effort to have a look what your colleagues are doing in other countries around the world. It was very frustrating. To the SMEs, the people that can perhaps develop and push these technologies. Academia are to prove the concept. It's to the commercial, it's up to the businesses to prove and commercialise a project. Don't expect somebody to do it for you. Have a look at past research that has been done. Before jumping on board a bandwagon and applying for funding, joining along a university, have a look to see if it's already been done. If it has, then you've got a quicker route to market. If it hasn't, and it's going through a full R&D funding stage, that's going to delay that technology by another 5, 6, 7 years. There are huge opportunities for an SME to grab hold of a new technology and push it forward. Small, medium enterprises are very agile, whereas its commercial competitors are stuck in their ways, they are used to their traditional methods. A small, agile company could certainly grab one of these technologies and run with it very quickly. And finally, to the farmers, to the skeptics in the room, the technology will be safe, it will have to be safe. None of the companies will afford or be able to afford putting a machine out in the marketplace that is unsafe. It will push back the investment in that technology if something goes wrong. Data management will be the key. No longer will you be repairing hydraulics, doing welding. You'll be looking at layers and layers of information, geospatial information, and it's up to you to interpret it to get the best knowledge, to get the best productivity, and get the best outputs from your farms. Don't be scared of it. These technologies are coming. They are not there to make people redundant. They are not there to make people feel inferior. They're not there to remove the contact from the farmer from the land. They are there to improve food production. Robots and automation isn't the future. It's not going to happen in 5 or 10 years. It's already happening now. Thank you very much.